Hi, folks. I'm off at my GSA conference today. Sorry I'm not with you. I'll miss you guys. Um, Anna Wood from the math department should be there. She's awesome. She can help you out with what you have to work with. I've given you an assignment that I want you to work on today and to try and finish up by Monday. Um, and she can help you out with that. Before you get started on that, I wanted to give you this quick 5-minute video um, that should help out with that work a little bit. And she can help you answer those questions as well that you might have as we go through this. Um, what I'm going to show you here is slides that match up with the slideshow that I've included in Classroom. Um, First thing I wanted to talk about was consecutive angles. We talked about this a little bit before. If you remember, our consecutive vertices are vertices on our quadrilateral that are neighboring or right next to each other. So if I'm looking at A here, my vertex A, if I traveled clockwise around my quadrilateral, I'd have a neighboring vertex at D. And if I traveled counterclockwise, I'd have a neighboring vertex at B. So another way to talk about those is consecutive vertices. The consecutive vertices for A are D and B, and the opposite vertex is C. Well, our angles here work the same way. Our consecutive angles for angle A, so angle A, that's right up here. Our consecutive angles are angle B and angle D, and the opposite angle would be angle C. So let's look at another angle. What if we were going to talk about angle D? What are our consecutive angles for angle D? Well, if you're thinking the consecutive angles for angle D are angle A and angle C, you would be exactly right. And our opposite angle for angle D is angle B. Alright, so our consecutive angles, the rest are neighboring angles. So if you take a look here, center that, we've got a quadrilateral here. What type of quadrilateral is this? If you're thinking that it's a trapezoid, you'd be exactly right because we've got a pair here of opposite sides. Segment IJ is parallel to its opposite side, segment KL. So I'll say that again. Sorry, it's a trapezoid because we have a pair of opposite parallel sides, segment IJ and segment KL. So one thing that we could notice here is that if we have two consecutive angles in a quadrilateral, and the side that's a part of those angles or if those two consecutive angles are supplementary, meaning their measurements add up to 180 degrees, the sides that those angles don't share are going to be parallel. So take a look here at angle I. It's got made up of this side segment JI and segment IK. This angle measures 113 degrees, so it's supplementary with angle K because 113 plus 67 equals 180. So angle K is made up of IK and KL, segment IK and segment KL. So the side that those two angles share is segment IK. The side that's a part of those two angles that are not shared are these two, top and the bottom here, segment IJ and segment KL. So those non-shared sides, segment IJ and segment KL, those sides are parallel. Those are our opposite parallel sides in this trapezoid. And part of the reason that that's true is because these two angles are supplementary angles. Their measurements add up to 180 degrees. If you think way back to when we were talking about transversals, basically this side here is acting as a transversal crossing these two parallel lines, and these angles would be our like same side interior angles. And we can see it over here with angle J and angle L. Those are both 90-degree angles. Those are supplementary as well, because 90 plus 90 equals 180. So here, two consecutive angles that are supplementary, that makes these sides parallel. Two consecutive angles here that are supplementary, that makes these sides parallel. Now, if we were to look at this quadrilateral, we would want to try and figure out, okay, is this quadrilateral a parallelogram? Well, it's not. We know that it's not. It looks kind of like it might be. It looks like segment BC and segment AD might be parallel, and segment BA and segment CD might be parallel, but we know that they're not, because if you add up our pairs of consecutive angles, like angle B and angle C, 105 plus 76 degrees, that's going to equal 181 degrees, not 180. So that means this side and this side are not parallel. And if let's try it over here, 105 degrees plus 80 degrees, that's 185, not 180. So that means that this side and this side are not parallel. So we know here that that segment AB is not parallel to segment CD, and segment AD is not parallel to segment BC. So here our opposite sides are not parallel because our consecutive angles are not supplementary. So this is not a parallelogram. It looks like it might be, but our angle measurements are telling us that no, it's not. What about over here in this slide? We've got EFGH, quadrilateral EFGH. Well, we can see from our arrow markers that yes, this is a parallelogram. That segment GF is parallel with segment HE, and segment HG is parallel with segment EF. So this is a parallelogram. Based on what we were just talking about, we can say that, okay, we can figure out all of the angle measurements here. We can figure out the measurement of angle E, the measurement of angle G, and the measurement of angle H, because we're given the measurement of angle F. Angle F is 50 degrees, so what are our other angle measurements going to be here? Well, if you look at angle F, take a look at its consecutive angles. For example, angle G, it's got to be supplementary with angle F. So it's got to have a measurement of 130 degrees because angle F has a measurement of 50 degrees. And same thing here for angle F and angle E. They've got to be supplementary because segment GF and segment HE are parallel. So 50 degrees plus 130, we've got 180. And if we follow that relationship again with angle G and angle H, we've got 130 degrees plus, well, we need that angle F to equal 50 degrees to make those equal out to 180. And then you could say the same thing with angle E and angle H. So because this segment and this segment are parallel, we know that angle G and angle F have to be supplementary, and angle H and angle E have to be supplementary. And because this segment, segment FG and segment EH are supplementary, we know that angle G and angle H, sorry, let me say that again. Because segment FG and segment EH are parallel, we know that angle G and angle H have to be supplementary, and angle F and angle E have to be supplementary, because this is a parallelogram. And this leads to the property of parallelograms where our opposite angles are congruent to each other. So we can see angle H is congruent with angle F, and angle G is congruent with angle E. So this property here, where if our consecutive angles are supplementary, then the sides that those angles don't share in common, the sides that are a part of those angles but that they don't share, those sides are parallel. This will help us figure out, okay, are we dealing with a pair of opposite parallel sides or not, if we're looking at a given quadrilateral. And also, if we know that a pair of opposite sides are parallel, it can help us figure out what our angle measurements are. So I know I said it was only going to be like 5 minutes in this video, and I'm like 11 minutes in. Sorry about that. Anna can answer more questions about this if you're not quite sure, but take a look through these slides on your own, and then try the questions that I'm sharing with you. Alright? I'll see you guys on Monday.